Now that we have the idea that we want to put together expressions by putting together primitives in legal ways, we can take up that idea of how to use that to start capturing recipes, start capturing algorithms. So let's talk about a Python program. Python being the language we're going to use in this class to do programming. And a program, just as we saw with the recipe, is going to be a sequence of definitions and commands. Definitions, as we'll see a little bit later on, are ways of either assigning names to values or, more importantly, creating procedures that we're going to treat as if they're primitives. Those we refer to as being evaluated. Commands are simpler expressions that we can execute directly within Python. And we do that in something called a shell. And in a moment, I'm going to use a shell. A shell is simply a window into which I can type expressions. They get passed into the Python interpreter. It follows a set of instructions to figure out what's the semantics, what's the meaning associated with that expression, and then it prints out the result. Commands are statements that instruct the interpreter to do something. So the commands could be simply do this arithmetic operation, or commands could be apply a primitive that I created to do some work for us. The last piece, and we're going to see both of these as we go through the course, is that we can either type things directly into the shell. That's a window that the interpreter is listening to. That's something where we type something in and the machine does something with us. Or we can store it in a file that gets read into the shell when we're ready to use it, but otherwise can be saved away. To start with, we're just going to type directly into the shell, but we'll see examples of files in a little bit. Okay, we're almost ready to start programming. We know the pieces we need. Let's start with what are the fundamental primitives that represent data. Those we call objects. And programs manipulate data objects in order to get out parts of those objects or to do something with those objects. Every object has a type associated with it that tells us what kind of thing it is. And more importantly, that type is really important, that type tells programs whether they can act on it or not. If a program is expecting a number and I give it a string, it's not going to try and do something with it. So the type of the object is really valuable. Finally, objects come either as scalars, which says they can't be subdivided, or if they're scalars, obviously non-scalars, which are things that have internal structure into which we can pull out parts. Let's start with the simplest version of these. Scalar objects in Python. There are very few of them. We have ints. These are integers, standard numbers that you recognize, 5, 17, 27, -6. We have floats. These are real numbers, things with numbers after the decimal point, 3.27, 3.14159, my favorite. You have something called a bool, short for Boolean, and that represents true or false. Those are going to be important when we get to tests, because we want to know if a test is true, do something. If it's not, do something else. There's one weird one. It's called none type. It's a very special one. It has only one value, which is none. We're going to see why that's important later on, but just to be careful, none type is a scalar object. Those are 4 fundamental scalars. There are only a couple of more which we'll get to a little later on. Once I have knowledge of those different types, I can also find out the type of an object by using a built-in procedure called type. And I want to show you some examples. So I'm going to go over to my little machine over here, and I'm going to skip down. I'm now talking to a shell. And you'll notice it's got a little prompt that says in, saying what's the input you want to give. The fact it's got 30 on the machine is because I was doing some other work earlier. So this is going to be the 30th expression typed in. And I'm simply going to type in a number. And the output is the number itself. Well, duh, you say. But it's actually important because what the machine did was it read in that sequence of characters, understood that it was a number, and the value associated with the number is simply the number. And in fact, I can check it because I can say, what's the type of 3.5? Notice the open and close parentheses around it, and it says it's a float. And I can have integers, and if I say, what's the type of that? It's going to give me back an int. Simple things. Okay. Again, just to recap, what this says is here's what I'm going to type in to this Python shell. And here's what shows up after I hit enter, as you just saw. And in and out are simply going to identify what I typed in the output that you've recovered. Sometimes I want to change types, especially with numbers. This is called casting, and I can cast types of different forms. And you can see the example. If I say I want to take an int, such as 5, and turn it into a float, I can ask it to do so by giving it the special command float, the thing contained within parentheses, and it converts it. The other direction also works. If I want to take a float, such as 3.9, and convert it into an int, here you say, boy, there might be some choices. Python simply gives the whole number part of it. It doesn't round it to the nearest integer, as you might expect. If you want to build your own programming language, knock yourself out, you could do that. But it simply will truncate it down to that int. So I can convert back and forth. Now, once I've got these things, I can start putting things together. And in particular, here's a legal expression, 3 plus 2. That has a value associated with it. And in fact, that expression is to take the 3 and the 2 and apply the arithmetic operation of addition to them. And when I evaluate it, it simply returns out 5. Makes sense. Sometimes I might want to use something that's going to print, and I can type, for example, print, which controls output to the console by saying print 3 plus 2. Little bit of a difference. And in fact, there's no out here because no value is returned. Print returns that none type and doesn't print anything out. It just printed something. At this stage, you may be saying, well, why do this? Why the difference? What we're going to see is when we're in the middle of a computation and we want to print something out to the shell, we can use a print command to do that. If we just return the value, that goes back into the computation to be used for the next step. And so in the simple first case, the whole value of the computation was 3 plus 2 equals 5. It was printing out 5. In the second case, the side effect is to print something. The value returned is nothing. There is no value. We'll come back to that as we go along. I've already hinted at this, but now we can start putting things together. To combine objects and operators into expressions, we use a standard form. And the syntax is simply an object, an operator, and another object. Any expression like this that is syntactically valid has a value, which is itself a type. So we talk about the types of scalar objects. We talk about the types of more complicated expressions. What would those expressions look like? Well, here's the first set of them. There's a lot on this slide, but you're going to get used to them, and most of them make sense. If I want to add together either 2 ints or 2 floats, my expression is to have 2 numbers, as I just did, 3 plus 2. The value associated with that is the combination of adding the 2 things together. I can subtract, I can multiply. And for these examples, if both I and j are ints, the result is an int. If either of them or both of them are floats, the result is a float. And let's look at an example. If I do 3 plus 2, I get 5. If I do 3.0 plus 2, I get the float 5. So Python is always using, if you like, the higher level representation when it does those kinds of operations. Division's a little trickier because I have both standard division, which will be a float, and I have integer division, which will be the quotient without the remainder. And let's look at 2 examples. If I do 5 divided by 2, I get 2.5. If I do 5 with 2 slashes divided by 2, I get the integer part, which is 2. The 0.5 is thrown away. And if I wanted to get the 0.5, I could do 5 remainder 2, which is the percent sign, and that gives me the piece left over when I divide those 2 pieces together. Finally, I can raise something to a power, and that is done right here with I, 2 stars, j. So 1 star is multiplication, 2 stars gives me power. Once I've got that, I'm ready to start putting together pieces. In particular, I've got different operations, so I have to think about how do I put together pieces in ways that control what I want it to do. And here we're going to use parentheses to tell Python in what order to do the operations. There's a precedence to those operations, and those are shown right down here, going in this order. Exponentiation, powers, are always done first. Then multiplications, then divisions, and then finally additions or subtractions. And overall, it's done in a left to right order as it appears inside the expression. And that means that as I change where the parentheses are, I'm changing the order in which I'm doing things. So to do an example, if I take 3 times 5 plus 1, that's going to give me 16. And that's because the multiplication is done first. 3 times 5 gives me 15, and then the addition is done to give me 16. On the other hand, if I say 3 times, and then in parentheses, 5 plus 1, the parentheses say reduce this expression first. Add 5 and 1, that gives me 6. And then do the multiplication, which gives me the 18. As a consequence, I can create very complicated expressions, and I will simply use parens, open and close, to define what operations to do first, always simplifying inside out before then using the operator precedence order in order to decide what the expression actually means.